All right. Well, first of all, thank you everybody for joining us. Good evening as well, and thank you to Good Batch for making this event. It's really a cool opportunity for us to present our product and ideas. And well, actually, also I've been told that this is kind of like a sold-out event, so which is also my first sold-out. So thank you all for being here. And yeah, so let me introduce myself a bit. My name is Adrian, or Adrian, or Adrián, depends on the language you speak. And I'm originally from south of Spain, and I studied telecommunications engineer. And up there you see actually what was my thesis about, which was wave-free synthesis. And this was my kind of like my prototype or my product back then, which was like literally a zero budget product or prototype, which was running, it was basically like 8 speakers running with 80s bunch of devices. So literally zero, no budget. And so actually, if you would ask me before, if I would need 1,000 speakers, then I would definitely not, not use that, since everything would run in my budget. And right after finishing university, I joined Holoplot around 6 years ago. And actually, one of my first tasks in the company was to screw, as you see on the bottom picture, 1,690 cables myself for the first prototype. So typical student job. And yeah, on the right side, that's me also 6 years ago with in front of the first Holoplot prototype. As you can see from my type and my physical look, I was still a bit more influenced by the tapas Spanish culture. And yeah, but coming back to the point and the title of the talk, why you need 1,000 speakers. Yeah, we just wanted to overcome and make even something bigger than this, which is the biggest sound installation and sound system so far. It's been used by the Grateful Dead in the 70s, and we just wanted to be cooler than that. Actually, we didn't, because that's fucking awesome. But yeah, okay, jokes apart. Actually, why you need 1,000 speakers, it's so that you're able to utilize and make use of, from my point of view, 2 of the coolest technologies in the audio industry so far, which are planar waves and wave-free synthesis. And just how do you achieve that? This is some inspiration from the theory, if you research a bit about wave-free synthesis. This is the first 2-dimensional speaker system that was built and running wave-free synthesis. It's been built in the 1997, and as you can imagine, the technology back then was way different than it is nowadays. So yeah, the feasibility of the product or of the idea was not really doable as it is right now. And that's actually a good point, or where we come as Holoplot, where we are proud to say that we are the first company that built a wave-free synthesis-based system that it's being commercialized, something you can buy. And for doing that at Holoplot, we build hardware and software both. And here you see, I didn't want to get too deep on the knowledge on the product itself. So basically, we have like an audio module that you can scale, you can make bigger and smaller. We have a core, like a processor that controls the audio modules, and of course, a software where you can completely steer everything in real time. But everything is kind of based on wave-free synthesis, and this is where I come into the next point. What is wave-free synthesis? How does it work? So if you imagine like a lake where, like a really calm lake, there's no waves, and you throw a pebble, like a small stone, then you will see like it creates, from this point where it drops, like, let's say it's like a water wave. So it will just spread with time, and it will get bigger, and if you put more of them, then they will just interfere with each other. So here's a small, simple animation. If you put multiple of those pebbles and you drop them in the water in different positions and with different timings, what will happen is that the water waves will crash against each other, and they will generate a bigger wave and also having a different shape. So at the very end, all the waves with all these different small drops will sum up each other, and they will create a bigger water wave, we can call them. So just to keep it simple and to summarize, here I just illustrate this summarized wave with a pink wave. And so basically what we did is you reconstruct the pink wave based on the small waves or multiple waves created from the small pebbles. So if you take those blue stones and make them on the same line, and you replace them by speakers, this is actually what Holoplot looks like. So you have a bunch of speakers that send small waves. And the big stone that was the pink, let's say, the pink stone that's the result of summing up all the small ones, the pink one, this is what we call a 3D audio object. So this is a pretty simplified explanation about what is wave synthesis and how does it look like. So yeah, that's cool, but I mean, what does it mean? What can you do with that? To understand more what you can do with it, then we can take the analogy with light to understand more what happens there. So if we take like these two analogies, the first one would be a light bulb. You all know how light spreads with a normal light bulb that you have at home. So what will happen is as far away you go from the light bulb, the brightness of the light bulb will decrease with the distance. And you cannot control at all what happens with light. You cannot decide in which direction lights will move from. And so that would be one scenario. Second one would be you have a planar wave. It's basically, you can take the analogy from a laser pointer. So you can imagine a laser pointer, and the energy of the light will keep constant over distances, actually really long distances. And you can also steer the laser pointer as you wish. So you can decide in which direction the light will focus. So those are like the two: spherical wave, we can call it here, or planar wave. And the cool thing about Holoplot is that we combine wave synthesis and planar waves, as I said before. And the coolest even more, it's that you can control everything with software in real time. And so you can pretty much design if you want to have a spherical wave or a planar wave. How do you do that? Actually, I create a couple of animations so that displays how you can control sound or light, as if we keep following the analogy. So if you have the audio object placed behind the system, you can, if you move it far away from the system, the spread of the audio will decrease. If you move it closer to the system, the spread will increase. So this way you can control the coverage of the sound in the room where the system is installed. And one really cool thing about wave synthesis is that these audio objects, you can even move in front of the system, where we'll create something that we call the focus source, or focus wave. And what happens is that the energy of all the speakers on the system will concentrate in one single spot of the room, which will create that there is an area of the room where the sound level is much more louder than in the rest of the room, and even much more louder than it is at the speaker itself. So pretty much you have like one spot where you hear something, and if you step out of this spot, then you don't hear that anymore. And that's something which is really cool and something that no other system literally is able to provide and to do. And also, as I mentioned before, since we have a two-dimensional speaker system, we can create planar waves. Those planar waves you can steer horizontally, vertically, as you wish. And you can even place multiple of those audio objects with the system. So you can define different directions, different shapes of the audio, and you can combine them as you wish. So, and you can even decide which content plays in which audio object. So you could define like 2 areas where you have different languages, for example. Cool. So it's all super, sounds really good, and it's quite exciting actually. But how does improve your experience or our experience, my user experience? So to do that, actually, I'm going to introduce the cooperation we are doing at Holoplot together with MSG, Madison Square Garden. It's an American company, where we both together are building the next state-of-the-art venue, which is pretty much focused on immersive experiences. And what happens there is that we're going to build like, or they mainly, we're just doing the sound. They're going to be like you can imagine like a planetarium. So it's like a spherical, completely surrounded video LED panel or like system that it's also matched together with a completely immersive audio experience, which is where Holoplot comes there. And outside, this is the 2 pictures that you see from outside, is fully covered with video as well. And inside, this is also as well with video, but much with audio. I just use this as an example of what, like, okay, you know already what can we do with our Holoplot and with word-based synthesis, but how do you use it in real cases? And here I just show like a couple of use cases that are much more focused on the pro audio industry. The first one is you will have a perfect source localization, which means if you have people speaking on the stage, you can perfectly localize that the audio source is coming from the exact position where the people or the person is talking from. And if you have also, you know, everything is combined with video. So if you have like video objects moving around the screen, you will always localize the sound from that particular object from the same exact position where the video is also playing that object. Second example here, it's what I mentioned before with planar waves. It's multi-content reproduction. So basically, it's just here an example. Imagine you have in this huge venue, you're playing a live match contest against each other. So you can pretty much divide the whole venue into halves, and each of those halves will have a different person talking to them, you know, with different commentaries or even with different languages. That's up to you, up to creativity. Third one, something you could do, or actually what you get already kind of like free. It's a high-speech intelligibility. This is basically, you get pretty much a dry audio experience, which means you have no room influence anymore about your reproduction. And this increases a lot the speech transmission between the person talking and the person listening to it. So you don't care anymore about the room. And last one would be you have a much more efficient reproduction. Since we're creating those planar waves, you don't need to send that much energy on the speaker itself because the energy will keep constant with the distance. So you can reduce, let's say, the level that the speaker has to play, and therefore you save energy, and that matters. And those are like just a couple of examples of what you could do potentially in such a venue with such a technology. There are also other use cases that we are also already involved in the businesses of retail, conferences, and public spaces. So here, with Deutsche Bahn already, we won 2 prizes. Actually, we won one yesterday. And in Plaza in London, we also won this week one. I just wanted to share with you because it's really exciting. And thank you. So it sounds amazing, and then you will be wondering, like, okay, so why is this not already on the concert where I'm going next week? Why can't I see that already? And this is to explain that I really like this quote from the CEO of Amazon, which says, every new things create 2 new questions and 2 new opportunities. And I wanted to share with you guys those opportunities and those questions so that potentially we can solve them together. And I just summarized that in 5 points. The first one would be the integration with established technology and workflows in the pro audio industry. It's something tough. There are really expensive equipment and software that are, let's say, not focused on immersive or on 3D audio object mixing, and So we need to find a way to find like an interface with them and to work together, since we cannot say just get rid of everything and buy something for us. Second point would be we need to get along somehow with 3D audio object formatting. So if there's any standard in 3D audio, I'm sure there is, but I'm sure it's not being used by everyone. So that's something we need to fight against or to create something. The third one would be there is a lack of education on the audio industry about everything that regards to 3D audio and to let's say, to mixing in content of this matter. And yeah, so I'm gonna get quiet here and say, let's get rid of stereo, please. And the fourth one, it's also what comes to us a bit. There are pretty few tools available for mixing and producing in 3D. Something that, yeah, the need is not there or was not there anymore, so that's why there are not so many tools. And this is also kind of like challenging for us to make people or not technical people use such a system or such a technology without like breaking their mind. And the last one is, of course, we require special content for that. And the content production mixing is a bit different than it is for stereo. So we need to influence those people in charge of the production since the very first stage of the production chain. So yeah, that's pretty much everything from my side. I hope that all together, we and you guys have those challenges and actually we transform them in 5 opportunities. So it's a chance for us to move the audio industry, let's say, to the next level. And let's hope that we get it together. Thank you.
All right. We have to switch this, otherwise it's not going to work, definitely. All right, are there questions from the audience?
When you said there are no tools right now available for this 3D production, then what do you guys do? You just do it all by hand, like very custom made line by line? And are you guys working on a tool, or is there some company working on a tool to make it faster?
Sure, there is already a software, definitely. It's been built by us, and it's just, let's say, a technical software. So it's not pretty much integrated into the DAV digital workstation, so it's not really fitted to the production stage. It's much more about like, we play as a speaker system, and we have a software that configures our system, but it's not, let's say, 100% fit and integrated with the production scheme. So yeah, we have something, but it's not enough.
Yeah, following a little bit on maybe on what was asked there. It seemed to me from what you mentioned in the challenges that it's mostly about tools and software, right? Not hardware. And more like you need more people to work with different standards or different tools. So what are you doing something towards that? Are you releasing I don't know, APIs, or are you releasing tools? Are you calling for developers to use them? What are you doing?
We're right now pushing every possible direction. So we have, of course, an interface where you can control our technology, and we are building ourselves a software team that takes charge of some of those points that I mentioned. And of course, there's always room for improvement or room for other people with different ideas and different mindsets as we have in Holoplot that are pretty much appreciated. So it's kind of like a work we need to do and a call for everyone to participate in that.
Any other questions? Yeah.
Do you plan to cooperate or challenge against Dolby, DTS, or Aura 3D with their 3D standards? I think they're quite different, but still go in the same direction, kind of, right?
Yeah, but we don't see them as direct competitors, since we plan to, at some point of time, if it's possible, to be compatible with those kind of formattings. We plan to go one step further, so it's not like we try to fight against them. You wouldn't go to a concert and find Dolby surround somehow whatever DTS concert. So yeah, it's like another topic, and we don't want to get mixed on that.
What's the frequency spectrum of the current system? What's the bandwidth?
It pretty much depends on the size of the system. As I mentioned at the beginning, it's a scalable solution. So you can make it one module, you can make it 64 modules. And this will give you like a multiple meters speaker wall. And we use, right now we measured already around 40 to 16, 20 kilohertz. And as I said, this influence a lot or depends a lot on the system size.
Any other questions? I'll go over there quickly and then right back to you.
In my last role, I did a lot of research on consumer perception of sound at Bang & Olufsen. And one thing we found was that after a certain point, it was kind of like 4K in televisions. Consumers stopped kind of really perceiving and valuing the sound beyond a certain point. Is that an education challenge? Do you see it Holoplot, or do you see, as you're working B2B, is the education purely on a B2B level?
We see the education more to have something which is not phantom-based, which is like how stereo works. And once you speak about resolution, on the audio, you have like a certain amount of degree resolution on horizontal and at vertical axis, and we just want to keep that. We don't want to say out loud, hey, we can do 0.05 degree resolution. It's not what we can do. It's not also what we want to achieve because it's not also practical. So we just want to, our call is more on, let's get rid of something which is not real and move to something that is more close to reality.
I don't think I've ever quite heard anything like that. Where could we experience that? If you're based in Berlin, is that possible?
Yeah, we are at in Tempelhof, so we have an office there. We're actually planning a C++ meetup for next month, so feel free to join if you are programmers or if you just want to hear the system. Otherwise, you can all the time, of course, send me an email and we can organize some demonstration, that's for sure.
All right, maybe one last question if there is one. Okay, there is.
Hi, thank you for the nice presentation. So I have a question about the product, the hardware part. Is there a unique size, or is it extended as, for example, N products in line or something? Or
What you scale is the speaker side, so the processor itself is just one. It doesn't change. You can scale the number of outputs, which is basically like a slot card that you put in there. And if you require more audio modules, you just need to plug more cards. But the processing of the system doesn't change, or it's not dependent on the number of outputs that you need to drive. And for output, I mean one audio module.
that's not my question actually, because when you talk about the product, I imagine there's a box with a lot of speakers as you show at the beginning. And so, as you say, there's just like the input is the number of channels. I mean, not channels, but the audio-based, specially placed thing.
Audio objects.
So yeah. So can you connect in series or this kind of thing? Several products to
Not so far.
extend and no.
So we can create 16 audio objects. This is independently from the number of audio modules that you can plug. So you can plug, as I said before, up to 64 audio modules. Every audio module has 64 speakers. So it's like a different concept. We're not speaking anymore about channels. We're speaking about audio objects, and those are pretty much related to the input streams that you can plug into the system. And this is pretty much now fixed on that. This is, of course, the current solution that we are selling, which is much more focused on the speech sector, let's say. For this project that I show here with Madison Square Garden, we're speaking about something different.
All right, I have one last important question. Would you recommend us to get a system here? For,
Always.
and yeah, price-wise, talk to Boris. I see so many use cases. We could have product crunch here, and no one is distracted in the other room. Yeah, so I think very valuable. No, thank you so much, Adrian.
Thank you, everybody, for listening.